Yeah, g'day, Mark here, and welcome back to my channel. This week, I'm working on reassembling my automatic tool changer for my CNC lathe. It's all in parts at the moment. I've cleaned it all, inspected everything. Other than a little bit of corrosion, there's nothing wrong with it. This 40-year-old seals had taken a set and it was all glued together with kind of varnished oil. If you didn't see the first video on it, this is what I'm talking about. My automatic tool changer for the Schaublin 125 CNC lathe. In the last video I got all the mechanical stuff stripped apart, and now I still need to pull the pneumatics apart. Our first valve is this one. Each of these valves has got a number of what look like close tolerance pins driven into them. I don't think they're removable. At least they don't give me the impression that they're going to be easy to remove. They don't even have any form of removal for them. There's no thread or anything in there, so I'm assuming those are permanent. There's another one there. I couldn't find my good circuit pliers, so I was having a bit of a challenge getting these ones out. I did get this out, and I did it just using a punch to sort of pull the circlip inwards, and then got underneath it with a scriber to sort of pick it out. Not ideal, but hey, got the job done. So here's the stack. Another little tiny O-ring on the inside. So this here I think is the directional control valve. Whoop, O-ring just flew off. So I'm kind of surprised they didn't put a threaded end in it so that you could just pull it out with a screw of some description. Some sort of a little plastic spacery sort of thing, I guess. So next off we need to somehow get this spool out. Got a little O-ring on it. Really don't like gripping this sort of thing with pliers, but there's really not a lot of other options, I guess. That's a beautiful close tolerance feel to it. Looks like we have from the inside we go shuttle valve, O-ring, spacer, O-ring, cap and circlip. When I put the scriber down in it, it certainly feels like it might be threaded. Yep. Next thing's also threaded, but I think this is M4. Another nice pilot valve. One thing I really do like about this Schaublin is almost nothing's corroded. Like the only corrosion I've found so far in pretty much this whole strip down was in the cap of the hall sensor. There's some corrosion down here and there's some corrosion on the sort of piston-y sort of matching piece to it. But otherwise it's all clean as a whistle. The wiring here just runs straight through the block into the conduit. It is quite interesting that this wiring got pretty beaten up and squished in production. All of it was beautifully run in the bits you could see, but the bits that were between the blocks here, it crossed itself a bit and ended up being a bit of a crushed up mess. Yeah, that's it. It seems to me that as soon as it gets a new set of seals, new set of O-rings, I'm guessing this should work fine. I think most of the leakage is probably just because the O-rings had taken such a set and become so squared off that they no longer sealed. Maybe just get that out like this. Oh, yep. I hate to think what this machine costs to manufacture. If this really was a one-off tool changer where all of these pneumatic components were made specifically to Schaublin's design for this one machine. Must have cost a fortune. In my last video, I said that this here, which aligns the tool holder to its base, is a Hirth coupling. And it was pointed out that on machine tools, these are often not Hirth couplings, but curvic couplings. I hadn't heard of those before, so I looked them up, and it turns out that Hirth couplings are just like triangular gear teeth, which this is, whereas curvic couplings have a radius bottom down here and radius top teeth to match them. This is the big O-ring which seals between the top plate and the main piston assembly. I think this is actually the main piston seal, because I'm pretty sure that it uses the whole area of this to get enough force to lift against that Belleville washer stack. I'm pretty sure that this is the main pressure seal for the piston to make the whole system work. It's the only obviously broken part in this whole machine so far. It was pointed out that I could just do a splice joint on this and glue it back together, but honestly, I really don't think it's going to work. I mean, it failed already. It's 40-year-old rubber or plastic which has been soaked in oil and grease for the whole time. I suspect this used to be a round formed O-ring, but now it's got sort of quite significant set to it. It's very flat on the outside and insides. I really don't think there's much point trying to save this one. I think what makes more sense will be to try and 3D print a replacement for it, mostly out of curiosity. TPU supposedly has quite good resistance to hydrocarbons, so it seems like it could be worth a while to try and do it like that. There's a website by a guy called Trilobyte. He's already taken a Schaublin 125 CNC with the same tool changer and got it running under Linux CNC. If you just Google Linux CNC carousel tool changer, you'll come up with this thread. There's the link to all of Trilobyte's pictures. And he also has some video showing the thing actually working. And what he did is gone to like a more of a normal sort of shaft seal. I visited Constantine in Belgium, and he's got a small one-man factory and has a 125 CNC, and he also modified this on his one. I think he also machined it out to use a normal sort of shaft lip seal. It is an option. I'm definitely not against doing that. I could mill that out, but I guess I'm just curious as to how well or if a 3D printed seal would work for this. So I whipped up the seal in Onshape and then exported it to Bamboo Labs and printed it. Let's take a look. Okay, so that's my first attempt at a TPU 3D printed gasket for this. Now the TPU looks like it's probably not quite dry enough. I've put it in the dryer since then. The next one I print shouldn't have all these warts on it. I also made the mistake of leaving the default top layer, which is like rectilinear, so it went backwards and forwards. I've told it to do concentric toolpaths for the next one. You've got layer starting points and end points. There's one here. It's kind of a shame that 3D printers don't have like an O-ring mode, because if you think about it, the thing could just spiral around the bottom, and then when it gets to the end of the bottom, it could go up a layer and then spiral back out, get into the layer, spiral back in, and each layer goes in, out, in, out, in, out, and not have those start and end point defects, wherever it was. This one was made with randomizing the layer starts, but it creates kind of a random wart at each layer. Now I can sort of cut these off. They seem to come off reasonably cleanly. So I'll go through and do that and see if that's enough to make it a reasonable seal. The other thing I've noticed is that this looks faceted, like the STL doesn't have enough segments for the curve or something. Not sure if that shows up on the video. I think you can get around that by having the slicer work with step files instead of STLs. So that seal's now in. Can get that seal on. Time will tell whether it actually seals properly or not. At least it should be better than one that's broken. I'm now just going through and cleaning up all these O-rings and measuring them so I can work out what I need to go and buy. I'm never really sure about measuring old O-rings because these have all taken a bit of a set. So this one's what, 3.8. 3.4. So I guess the average would be 3.6. So I'll put that down. Yeah, let's call it 22. Right, well, I'm a bit behind schedule this week because I was out a couple of evenings. My wife and I went to the Baz Luhrman epic movie, Elvis Presley in concert. I'm not an Elvis Presley fan, but it's actually a pretty good movie. You should go and have a look at it. Very sympathetic, wanting to give his audience everything, give it his best. It's kind of cool. Washing and inspecting all the parts probably took me a couple of evenings. It gets kind of boring, so I won't show much of that. Okay, well, I've got all the O-rings that I ordered, so it's time to start reassembly. Now, the first part I'm going to reassemble, I think, is going to be this here. Now, to work out how this goes back together, I'll just quickly re-watch the disassembly video. So, what do we need here? We need one more of these O-rings. And then this one goes in this cover. Let's put a little bit of oil on the O-rings. Wait a minute, that doesn't look right. Two of those spaces, one on top of one another? I don't think so. Let's take all this back out. I think I got that wrong. Okay, well, I took another look at the video and looked at the cross-sectional drawing, and this is the stack I needed, so I did have it wrong. This one was a bit of a beast to get out, so I'm sure it'll be a beast to get back in. Last bit here is one of the little knobs goes on. Right, here's the next module. Okay, now the shaft of this spool valve did pick up a bit of pitting corrosion down here. So what I'm going to do is just spray on some corrosion prevention. Just let that dry for a bit. Obviously I'll clean it off the spool valve itself, but the shaft's not really a part of the pneumatic system, it's just to move it. Mail time. Just a replacement USB cord. This is one of those high temperature silicon ones. I need it for my pencil soldering iron, and the one I had, I by mistake, I don't know, got caught up or something and ripped the connector off the end of it. That was dumb. Don't forget to wear gloves when you're in the shed. Because I killed my heating elements on my ultrasonic cleaner, so I got some replacements, but I needed the glue to glue the new replacements in. So I've had these bearings soaking in WD-40. That's washed the horrible gunked up grease out of them really nicely. I did consider replacing them, but really these are static bearings. They've done basically no work. There's no corrosion on them because they were protected by a layer of sort of varnished cutting oil. I'll just give them a lube and put them back together. Now to lubricate the bearings, I did consider using some Kluber, but this stuff's very expensive and it's designed for high-speed spindles, and this is not a high-speed spindle. I'll just use the good old regular general purpose grease. That's already coming through, so I'll just do a bit more from the other side. I must say it is really helpful to have the video of taking it all apart to help put it back together. It has to go together in two parts because this part goes in from the top with its bearing seating in here. And then from the other side, just wondering whether I should spray some anti-corrosion stuff in that first. Maybe I will. Let's get some grease on the pinion. Make sure this doesn't start rusting. Then comes the bearing, but it doesn't center on anything until the housing goes on. I need to look at the video again to see which order this goes. Okay, I just rechecked the cutaway drawing and this goes under the bearing. So I need to pull it apart again. You tighten just a little bit more to get to the next tab there. Now you can see there's a witness mark or alignment mark here on the cog and one here on the housing. And I went back to the old photos and that showed that those were also lined up before I pulled out this. What I'm guessing is that that's the way it's supposed to go back together. Aha, look. I'm probably one tooth off here, so let's push this back out. Go one tooth beyond. Or do I need to go even one more? Because that's where it was stuck before. And yet it looks like I'm still another tooth off. So past it. So with that aligned, the piston's basically where it was when I pulled the thing apart. Seems to move nice and smoothly. That's good. Right, I need a new O-ring in there. Right, next up we need this to go through from the back. And it's also got an O-ring on it. To get these together, there's 4 locations where this can be mounted. So they obviously need to be clocked in with this gear as well. So let me just give myself some witness marks. This is the drive lug for the main tool holder and it needs to be somewhere down about here. So that means I need, whoops, I think I've just marked the wrong pair. I need the mark across this pair. So I want that mark to line up about there. So that feels like it's now down on those pins. That's good. And my alignment mark here is still correct. Now if you look down here, you can see that I had some corrosion down in this area beforehand. So the next thing that's going to go in is going to be the Belleville washer stack. But before I do that, I think I'll just spray some more wax anti-corrosion down in there and also lube up the Belleville washers properly. I was told to use moly disulfide dry lubricant on these first, but I don't have any. But I do have wet moly disulfide grease, so that's what I'm going to use. So this here is the spring stack. These are Belleville washers. They're just kind of like dished washers. These are a very good way of making a very strong spring if it doesn't need too much extension distance. You can adjust the spring pressure by how you stack them. If you stack them together like this, you double their spring force. If you stack them this way, you increase the travel. This spring holds this whole assembly down onto the Hirth coupling and also onto the studs which align the thing, and that's what gives you the nice rigid static positioning of the tools, and it's the air pressure that has to fight against this Belleville washer spring to be able to lift this whole module. On the upper side of the Belleville washer stack is this cap, and this is probably one of the most corroded parts. See, it's got some quite nasty pitting corrosion in it. I've removed the rust using rust remover and then the wire brush, and I'll give this all a good spray with a corrosion resistance wax. Right, I can put these 6 screws back in which hold the Hirth coupling. Didn't need to take them out in the first place. Uh-oh, wait a minute. I thought this was the thrust washer which sits on top of here, but actually there's a little one that sits there. This one should have gone in here under the Belleville washer top hat section thingy. So I need to pull this back off again. I think I stuck this down with grease. I'm going to have to pull it out a bit. The next thing to be installed is the valves, because I need to run the wiring through before I can put this top plate on. So the first valve goes on easily. That's just a block coming in from the side. Now because here I've got a mix of aluminium, brass or bronze and cast iron, well, it's probably great if you like a bit of corrosion. Ah, wait a minute. I was hoping that I could mount this then this, but because this valve shaft goes through the other block, that has to be at least loose to be able to do it. And you can see here that last time this was installed, these wires were not dressed properly and they were crossing each other. Somebody cranked this up against them and crushed all the wires. It would not surprise me if I've got broken wires inside some of these, but I won't know until I've actually got the thing all set up. What I think I'll do now is just loosen this back off, try and dress these wires in a way that they don't cross each other. They basically have to come straight down, round that reasonably sharp corner, up that way. I might just try putting a little tape around them and seeing if I can help manage them a little better. And if any hope that the tape's going to stick, I'll just degrease it a little bit as well. One of my YouTube members in Germany, Alexander, gave me this very high strength 3M somewhat padded tape. Okay, let's see how well that's going to work for me when I try flipping it up. Right, next up is the top plate. That's the one that gets my new seal that I made. And also there's the little thrust bearing which goes in here. Plenty of grease to keep that stuck in place and to lubricate this area. I was kind of wondering whether I should lubricate these gears with grease or with oil. I guess it's actually grease, isn't it? Oh, bugger. Oh, I just realized that I think I forgot to put some seals in. I definitely need seals on here, but I'm pretty sure I also needed seals between these two blocks and between this block and the main body. Well, I guess I better see whether I can get these seals in without a complete disassembly or whether I have to go back 10 steps. That was stupid. Okay, so I got those seals in. Now I still need to put in the final block. That's this one. Now because this whole tool change is controlled purely pneumatically and the electrics are only used for feedback of position, theoretically I should be able to test this now. So let's put it up on the lathe and see if it'll work. Right, air on. Yeah, I've got a good... Definitely got air leaking from this block. Definitely got air leaking in this area. Oh, it's not doing anything good. Since I don't know which of the two lines is my pressure line and which is my change line, let me just switch them over and see if that makes a difference. Okay, now with the pressure and tool change lines switched, huge leakage here, so huge leakage out here. Right, well since air is blasting out of this block regardless of which way around the supply lines are, let's whip that back off and see if I've missed a seal or something in there. Certainly wouldn't surprise me if I've missed one on the shaft because the air is blasting out past the shaft. I've definitely got the two seals in there. Okay, so I've stripped down this valve block again. Looking at the main spool valve on it, I think the problem is that I measured up these O-rings as they came out and got replacements of the same size, but they're simply too large. They're not forming a seal between the spool and the O-ring, and therefore the air's just blasting straight on by. So it looks like I'm going to have to leave this video here and go through and order some more O-rings which I can pick up next week, which are going to be smaller diameter and should actually then seal. So that spool's a bit over 3/8 of an inch, and I guess I'm going to need a little bit of tension on the seal, so I'm guessing I want a 10.5 millimeter inner diameter seal. Can't remember what I ordered. Yeah, it looks like I got an 11 millimeter seal, maybe even 11.5. Oh darn. I'll have the same in the other valves as well, so I'll probably have to pull it all back apart and replace all of those spool valve seals because I'm sure I used the same size on all of them. Now, although I'm an aircraft mechanic and we of course change O-rings all the time, it's standard on aircraft. Whenever you remove an O-ring, you always replace it, you never reinstall it. I've just realized that I've almost never measured these things before. In aviation, you just look up the part number in an illustrated parts catalog, order it from stores and install it. So if I have a 10.5 millimeter shaft and a 16 millimeter bore, leaving 5.5 millimeters of gap, what's typical for sizing an O-ring? Should I be looking for 2.75 millimeter thickness O-rings, which would be like the theoretical perfect fit, or do I need something, a 3mm wall thickness to get a bit of crush on there, to get a bit of sealing? Put in the comments section, how do you guys go about sizing O-rings? Sorry not to get this job finished this week. I'm a bit disappointed about that. I was hoping to have this running, but them's the breaks. Hopefully I'll have it done next week. See you then, and thanks for watching.